So guys, in this video, we are going to solve some numericals based on welding, and this question asked in gate exams. Like this question is asked in 2005 gate exam of 2 marks. So let's see how we can solve this question. So in this question, spot welding of two 1 millimeter thick sheet of steel density of 8,000 kilojoule kg per meter cube is carried out successfully by passing a certain amount of current for 0.1 second through the electrodes. The resultant weld nugget formed is 5 millimeter in diameter and 1.5 millimeter thick. If the latent heat of fusion of steel is 1400 kilojoule per kg and the effective resistance in the welding operation is 200 microohm, the current passing through the electrode is approximately. So we have to calculate in this question the current passing through the electrodes is. So how we can solve this question? So they are given latent of fusion of steel as 1400 kilojoule per kg and the diameter is 1.56. So let's see how we can solve this question. As you know that mass of nugget equal to volume of nugget and density. They are given density, and how we can calculate volume of nugget as pi by 4 d square h into p. So here the value is 5 and the height is 1.5, and we are given the value of p as 800, density as 8000. So we can calculate mass of nugget as 235.5 into 10 power minus 6 kg. Now for heat balance, heat developed is equal to I square RT. And how we can calculate heat developed? So guys, they are given latent heat of fusion of steel as 1400. If you multiply mass of nugget by this heat of this latent heat of fusion, then we can equate it by using this formula I square RT. Now 1400 into 235.5 into 10 power of minus 6 into 10 power of 3 is equal to I square into, they are given the value of resistance as 200 and the value of t is 0.1. After that we can simplify and we can calculate the value of I as 4060 ampere is the correct option for this question. So that's how we can solve these questions based on welding, spot welding. Now let's see the another example of welding. So in this question, in an arc welding process, the voltage and the currents are 25 volt and 300 ampere respectively. The arc heat transfer efficiency is 0.85. So they are given the arc heat efficiency as 0.85 and welding speed is 8 millimeter per second. So now the net heat input. So we have to calculate net heat input in joule per mm. So we have to calculate that. So how we can calculate this? So guys, we know by using this formula as the net heat input as equal to efficiency of arc heat transfer into V into I by V. Here V is the voltage and I is the current, and the down and this V is equal to the welding speed. Now we know all of these formulas. Now we have to put the value of voltage, current and the efficiency and the welding speed so that we can calculate the value of Q as 797 joule per mm. So that's how we can solve these questions. So remember this formula and please note down in your copy, because this formula can be helpful in calculating the heat input in joule per mm. So I hope you understood this question. Now let's see another example of welding. So in this question they are asking for spot welding of two steels each of 3 mm thickness, welding current of 10,000 ampere is applied for 0.2 second. The heat dissipated to the base metal is 1000 joule. Assuming that the heat required for melting 1 millimeter cube volume of steel is 20 joule and the interfacial contact resistance between sheets is 0.0002 ohm. The volume of weld nugget is, so in this question we have to calculate the volume of weld nugget. So how we can calculate? So guys, we know they are given dissipated to the base, heat dissipation as 1000 joule, and they are also given the resistance as 0.002 ohm. Now we have to calculate the volume of weld nugget. So guys, we know the relation S is equal to I square R plus K. Here K is the heat loss. If by putting all of these values we can calculate the value of K, then we can simply simply we can put K is equal to mass of the nugget and the latent heat of fusion, and after calculating mass we can calculate the volume of weld nugget. So that's how we can solve this question. So remember this formula. This is very helpful for solving this type of questions. So I hope you understood all of these questions, and this question we asked in 2014 set 3 of gate paper. So guys, if you want to solve more multiple choice question based on gate, SSC, JE or mechanical engineering subjects, then please visit robojala.com, and for more videos please subscribe my YouTube channel Meg Ujala.